Okay, here's the vectors question on this paper. We're given the coordinates of A and B, so effectively we've been given the vectors OA and OB. Really, to be those, they should be written as column vectors, but that effectively is the information we've got. And then to get the vector AB, we just need to do the right thing with these two things written as column vectors using the normal method. And then a vector equation of the line L1, which is a line that goes through A and B. There's only one mark for this because actually the vector we've already worked out is halfway to getting the equation of the line. Remember, we need two things. We need a position of a point on the line, so you could use either of those, and you need a direction vector, which we've got, and then you use the standard formula. Don't forget to start with r equals or xyz equals. Use the standard formula for a straight line, which is in your notes. Slot in the position and direction vectors, and you've got that mark. Okay, then the line L2 has got this equation, and we've got to show the point. This point lies on L2, and to do that, all we need to do is show that that point can come from this. So we need to come up with a value of mu that generates this point. So the first step is to spot which mu works, and for that you can say, if I'm aiming for -2 as my x-coordinate, what value of mu do I need so that these two bits combine to give an answer of -2? So you'll be able to say what mu has to equal, and then you need to show that the y and z coordinates work out correctly for that value of mu, and that will get you 2 marks. But the biggest part of the question is this one, B part 2, with 6 marks. Q is on L1, PQ is perpendicular to L2, and we've got to find out where Q is. And you do have a worked example of exactly this method in your notes. But what we've got to do is start with the given condition, PQ is perpendicular to L2. And perpendicular calls for a particular method. In fact, I'm going to have to give the game away on that one. But your notes will tell you the test for perpendicularity is you're going to dot product, scalar product, two things, and the answer to the scalar product has to be 0. So the two vectors we're going to dot together, one is going to have to be PQ, and the other is going to be a vector in the direction of the line L2. So here's the line L2. You need to pick out the direction vector from that line. You're going to write that as a column vector, but you can pick it straight out of the equation of the line. So that's a known vector. The vector PQ is the one you're going to have to work for a little bit. You're going to get PQ in the same way as you got AB. You're going to be doing OQ minus OP. Now OP is alright because we've got the coordinates of P, so that effectively is the vector OP. For the vector OQ, all we know about Q is it lies on this line. So we can take OQ to be this. We'd have to know the right value for mu. You can call it little q or you can leave it as mu. But if you take this whole expression here, then that will be your OQ. So you can have OQ equals, and normally we compress this into a single column vector. So I'll do the x bit for you. It's going to be 1 plus, and then 1 times mu is mu. I'm leaving the parameter as mu. And you do the same thing for y and z. Your y1 won't have any mu's in at all, don't worry. And that's going to be your vector OQ. And then you're going to do OQ minus OP, so you're going to subtract the column vector form from that. And you're going to get a vector PQ, which has got mu in its components. Maybe not in the y1, but it will be in the x and z one. And then to complete the solution, you're going to take that vector PQ, which will have a mu here and some other numbers and some more mu's down there, and you're going to dot it with the direction vector, which has come from the line, and you're going to say the answer is 0, and you're going to end up with an equation with mu's on one side. So when you simplify this, you're going to get some numbers, and some number times mu equals 0, which will tell you what mu is. And once you know what the value of mu is, you want the coordinates of q, so you go back to the vector OQ, put in your value for mu, and out comes the coordinates of q. And it's worth coming back to this question time and time again, because it is a standard set piece you're supposed to know. If that was all too brief, then I do promise you have an example in your notes which you can look up and study at your leisure.